Hello everyone, how are you? We are completing here in part 3 of solving paper 2 multiple choice extended for May-June 2025 variant 22. In the previous two parts we finished until question 20 as I remember. So today we're going to complete from 21 till 30. Okay? Let me go fast down here more and more, and then until, where is that? Okay. Now here we finished until 20. We're going now to complete from 21 until 30. So let's read question 21. It says a ray of light traveling in air is incident on an air glass boundary. The angles between the incident ray, the refracted ray, and the boundary are shown. Okay, they want now which equation is used to calculate the refractive index. Okay, let's remember a refractive index can be given in many formulas. One of them is N equal sine incident angle over sine refraction angle, right? So where is the incident angle? Incident angle is between the incident ray and the normal. Okay, let me use another color here. I'll use this one. So this will be the incident angle, right? So in this case, incident angle will be, okay, it is going to be all this 90 minus the 50. 90 minus 50, which equals to 40 degrees, right? Where's the refraction angle? Refraction angle is between the refraction ray and the normal. So this will be the R, okay? Which means refraction angle here equals to 90 minus 64, which equals to 26 degree, of course. So it's going to be sine 40 over sine 26. So this is 40 and this is 26. Which option is that? It's actually option A. Okay, I hope it's clear. Now question 22. A small object O is placed near a converging lens as shown. The lens form an image I. So this is the object O here, and here is the image. Okay, which statement is correct? We're looking for the correct statement. They say the image is diminished. As you can see here, the object is a point and the image is a point. Okay, I cannot see if it is like diminished or enlarged. Okay, so it's not clear. They say the image is inverted. Also, it's only a dot. I cannot check. They say here the image is real. Okay, I hope you can differentiate between the real and the virtual. Remember, if they are on one side of the lens, like here, both of them to the left, object to the left and image to the left, okay, so this is virtual. Okay, if it is real, one will be left, the other will be right. So option C is wrong. In D, they say object is closer to the lens than its principal focus. Where is the principal focus? Actually here. This is the principal focus. How do I know? Because notice here, the ray of light will go there and it will refract in this direction, where if you take the extension of it, it will go through the principal focus. Okay, so the object O is closer to the lens. This is correct. The option is D. I hope it's clear. Next question. What is the approximate speed of light in air? This is a number that you should memorize. It is 300 million meter per second, which is 3 multiple 10 to the power 8 meter per second, which is option C. Okay, I hope it's clear. Okay, this is a value that you need to memorize. Okay, In question 14, it says a ship sends an ultrasound pulse to the seabed to measure the depth of the sea. Okay, the speed of ultrasound in seawater is 1,500 meters per second. This is the speed. The pulse takes 4.6 seconds to travel to the seabed and come back to the ship. Okay, so it will come back to the ship. What is the depth? Okay, so this actually for the sound to go deep down and return. Okay, and so here they want the depth of the sea, which means that here this time I need to divide it by 2 because I need only the time needed to travel down or to travel up, right? So it's going to be 4.6 over 2 is going to be 2.3 seconds, right? So I want now the distance is going to be, we know already that speed equals distance over time. I need the distance is going to be speed multiple time, which is 1500 multiple 2.3, and the answer will be approximately like 3,450 something, right? So which is yani close to option C. Okay, I hope it's clear. Please pay attention in this question, in this type of questions, if they tell you that the light is coming back, I mean the sound is coming back or no. Okay, if it's not coming back, so no need to divide by 2. Okay, good. Next question, they say a dolphin has a range of audible frequency of 150 Hertz to 150 kilohertz. Which range of frequencies can be heard by both human with good hearing and dolphins? So dolphins, I know they gave me the range here already. And for the human, I should remember that it goes from 20 Hertz to 20,000 Hertz, which is 20 kilohertz. Okay, I hope we know this. So I need to choose which range of the following A, B, C, D. Here, from 20 Hertz to 150 Hertz. No, I guess the dolphin cannot hear here. This one, no. Also from 20 Hertz, the dolphin will not be able. Okay. Here in C, they say from 20,000 to 150,000. So here the human cannot hear. In D, they say from 150, accurate for both of them, to 20,000, accurate for both of them. So the option is D. Okay? Please focus when you compare these numbers. Okay? Sometimes it's tricky. Now, question 26. A positively charged balloon is placed against the wall. The charge makes the balloon to stick to the wall. It means the positively charged balloon is attracted. Okay? They say here, which statement explains this? Now, in A, they say positive charges on the balloon attract electrons on the wall. This is possible. Positive charges on the balloon attract protons. No, wrong. Protons are positive, right? So positive do not attract. So B is wrong. Okay? In C, they say positive charge on the balloon repel electrons. Actually, this is wrong because positive attracts negative. C is wrong. Okay? Now they say positive charges on the balloon repel protons in the wall. This is also possible. So which one do I choose? Pay attention, they say it will stick to the wall. Since it sticks to the wall, so we should take the attraction, right? So it's option A. I hope it's clear. Now, question 27, a student is trying to determine the resistance of a lamp. He sets the he sets up the incorrect circuit. So there's something wrong in this circuit. Which change would allow him to take the measurements needed to calculate the resistance? Okay, so in A, they say disconnect the emitter and move it to the left. It doesn't matter the emitter if you put it here or put it here or put it here or put it here or put it here. It's the same. So there's nothing wrong with the emitter since it is connected in series. So this option is wrong. Now they say in B, swap the position of the ammeter and voltmeter in the circuit. Like change position, this here. Also, this will not affect anything, okay? Because again, we know that ammeter is in series. It doesn't matter where you put it. Then they say in C, disconnect ammeter and connect it in parallel. Wrong. Ammeter should be in series. In D, they say disconnect voltmeter and connect it in parallel. This is correct because voltmeter should be in parallel. So here, I have to put the voltmeter right here. Okay? Either like you put it up here or you can put it down here. Basically the same thing. The important thing is that it should be in parallel, right? This is question 27. Now let's go to question 28. It says metallic wire X has a resistance. What is the difference in resistance for a wire of the same material as X that is, first, shorter than X but same diameter? Shorter than X, remember here we should remember that resistance is directly proportional to the length. So shorter, it means less resistance. Now in this point they say the same length but smaller diameter. Remember also resistance is inversely proportional to the area, which means it's inversely proportional to the radius, which means it's inversely proportional to the diameter. So when they say smaller diameter, I have larger resistance. Let's choose between the options. Resistance of shorter wire, we said is going to be smaller. So we are in option C or D. A is wrong and B is wrong. Why? Because it's shorter wire. It means less length, which means less resistance here. Okay? So in the resistance of wire with a smaller diameter means more resistance. So it's going to be this one. Okay, the option C. Question 28, option C. Here in question 29, the diameter shows the circuit for a potential divider. Okay, let me use this color. Which equation is used to calculate V1? Pay attention that V1 is the potential difference in R1, V2 is potential difference in R2. Okay, they want me to check which formula gives me V1. Okay, no, sorry, I should be here. Okay, so let's remember, what's the formula? Potential divider, we know already. R1 over V1 equal R2 over V2. Okay, you can write it in a different way, which is R1 over, over R2 equals V1 over V2. You can write it like this, doesn't matter. I hope you know that you can write it in both ways, okay? So from here, from this one, I can find V1. Let's do cross multiple. Cross multiple is going to be V1 multiple R2 equals R1 multiple V2, right? So I need now V1. I write here V1. I have to divide both sides on R2, right? Then cut R2 with R2. I will have R1 V2 over R2. Okay, which option is that? It's option B, right? It's basically the same thing here. I hope it's clear. Now the last question for this part 3. They say which electrical device is used to convert AC to DC, alternating current here to direct current here. Okay, let's remember, in the alternating current, I have like the current will be up and down, up and down, up and down. Okay, so it goes in two directions. Okay, to prevent it from going in two directions, I have to use a diode, because the diode will allow one direction and stop the other direction. Okay, remember, this is the diode. Let me remind you, this is the diode. So if the current is going in that direction, it will pass, right? But if the current is coming in this direction, it will not pass. Okay, so we use a diode to change alternating current to direct current. I hope it's clear. Please feel free to ask any question, okay, in the comment section, and make sure to subscribe. Have a nice day. Bye bye.